Hello, IB students. Today we are exploring topic 1.6. So this is in topic 1, number in algebra, and 1.6 is talking about proofs. So today we're going to look at algebraic proofs. And you may remember studying proofs in pre-calculus or trigonometry, where we had to prove the left-hand side equal to the right-hand side. This is the exact same idea. We're just not looking at any trigonometric expressions today. So simple deductive proof, numerical and algebraic, is one of the requirements for our course this year. This is the first year we've had this included. And so what we want to make sure is that we know to lay out our left-hand side and our right-hand side, and we're only going to work one of those sides. And they've got a couple of examples built into the subject guide. This is actually what's listed in our subject outline, our syllabus guide. So we're going to do a couple of those examples today. Left-hand side and right-hand side proofs require students to begin with the left-hand side and transform it using algebraic steps into the expression on the right-hand side, or vice versa. So when we are working a proof, there are a couple rules we want to remember. First of all, we know that the goal is to make one side look like the other. You cannot move terms from one side to the other. So this is not solving an equation. We're just going to transform one side. And then at the end, you can write a concluding statement. I'll usually write QED. QED is a phrase that means what was to be demonstrated or what was to be shown. And this sign with the 3 bars, you're going to see that pop up every now and again, is called the identity symbol, and it means that the two sides are equal by definition. All right, so let's take a look at a few examples. So the first one is stating, show that 1/4 plus 1/12 equals 1/3. So I'm going to work on the left side, and I know that I want to try to add these two fractions and prove that it is the same thing as the right side, which is 1/3. So I'm going to rewrite this 1/4 with the common denominator of 12. So that would be 3/12 plus 1/12. I'm going to bring down that right side. 3/12 plus 1/12 is 4/12, which simplifies to 1/3. And that is what they wanted us to justify, and we've done that. Okay, so we've seen an example with numbers. Now let's take a look at an example with variables. And this actually is an algebraic form of this numeric example. For example, if m were 3, m plus 1 would be 3 plus 1, which is 4. M squared plus m, 3 squared would be 9, plus 3 would be 12. So we've shown that it works with a numeric example, but really if we can show that it works algebraically, then it works all the time. And then you can apply it to any relationship that has these same algebraic expressions. All right, so what we're going to do is add these two together. When I add fractions, I like to factor my denominators. So I'm working on the left side. In the denominator, I'm going to factor m out. That leaves me with m plus 1. I'm going to bring over that 1/m. And I want to find a common denominator here. So I know I need an m plus 1. I also need an m. So m times m plus 1 would be our common denominator. And what we're going to do is look for what this denominator is missing to turn it into this new least common denominator. It's missing an m. So I'm going to multiply top and bottom by m, which leaves me with m over m times m plus 1. And this already has that denominator. And now I'm ready to combine these together. So our denominator remains the same. So we add our numerators. And then I'm now seeing that this m plus 1 on top will simplify with the m plus 1 on the bottom, which reduces all the way down to 1/m. We have just proved the left side is equal to the right side, and we are ready to move on. Okay, let's take a look at one last example. So example number 3 should look familiar. We've done problems like this before. So this is just an algebraic expression on the left. We want to show that it's equivalent to the one on the right. So in order to make the left side look like the right side, let's expand out this binomial. So this would be x squared minus 6x plus 9 plus 5, which is x squared minus 6x plus 14. That was a nice easy one. And we've proved that the left side equals the right side. Okay, so that is one type of proof. These are algebraic proofs. Thank you so much for listening. Good luck to you.